Hello everybody. Today I would like to introduce to you InfraBox, a next generation CI platform. InfraBox is an open source project with the goal of efficiently executing your continuous integration tasks. We have 3 GitHub repositories. The first one is InfraBox itself. Then there's a command line interface which you can use to interact with InfraBox, and there's an example repository. It contains examples for almost all our features. Every job on InfraBox runs in a Docker container. As we will see later on, this gives us some huge benefits. Everything, including InfraBox itself, also runs on a Kubernetes cluster, so every task you schedule will be run on a Kubernetes cluster. InfraBox is built with a cloud-native architecture, so you can run it on any cloud or on-premise wherever you have a Kubernetes cluster available. There's also a free hosted version of InfraBox at infrabox.ninja. You can use it to run your first CI jobs on InfraBox. Before we now start using InfraBox, let's first have a look at a traditional CI pipeline. In most projects, we first start with compiling our project, then run a first set of tests, maybe another set of tests like end-to-end tests, even run a benchmark, and then deploy our application if we are happy with our test results. When we now look at the resource consumption of our tasks, then we see that some of our tasks actually don't use many resources, but others, like the compilation, takes a lot of resources. As we run all of them sequentially, we may waste a lot of resources. Actually, we would like to run multiple pipelines in parallel to make best use of our resources in terms of memory and CPU. This can be quite challenging because just running tasks in parallel without any isolation may lead to sporadic failures if another task uses too many resources. Such problems can be handled with InfraBox. But first, let's go back to our pipeline. Instead of running all our tasks sequentially, we can also build a task graph and run some of them in parallel, like the tests and the benchmark. In the following step, let's put all our tasks in Docker containers. By running all tasks in containers, we can much better isolate the different tasks from each other. Another consequence is that each task can define its own environment, so you don't have to configure your build machines to satisfy all your tasks. Last but not least, we can now assign resource limits for CPU and memory to each task, so you can make sure that each task gets the resources it needs. Let's have a look at a simple Hello World pipeline. All you need is a Docker file which describes your task. In this case, it will simply print Hello World. The second thing you need is the InfraBox JSON file. It contains the job definitions of your project and should be in the root directory of your project. For this example, we define one job. The type is Docker as we want to run a Docker container. There are also other job types like Docker Compose if you want to spin up multiple containers for your tests. We give the job the name example1 and specify the path to the Docker file. As we would like to build and also run our container, we set build only to false and set CPU and memory limits accordingly. Now we can execute InfraBox run to build and run the container on our local machine. If you don't want to run your jobs locally, you may also use InfraBox push to send it to an InfraBox instance and run the jobs on a Kubernetes cluster. But of course you can also connect your Git repository to InfraBox and automatically trigger a build every time you do a Git push. Let's move over to infrabox.ninja, a hosted version of InfraBox which you can use to run your jobs. It's connected to github.com, so you can log in with your GitHub account and connect your repositories. Here's the project overview page. This is for InfraBox itself, as we also build and test InfraBox on InfraBox. You can see all the builds which have been executed so far. Let's select a build to see some more details. InfraBox visualizes all our jobs and their dependencies. In our build graph, we first run a set of unit tests. After that, we build all our Docker containers and push them to a registry, so we can use them in the next step for our end-to-end tests. To To run our end-to-end tests, we use a Docker Compose job, which pulls the images again and spins up an InfraBox instance using Docker Compose. It's also possible to get a Kubernetes namespace provisioned by InfraBox, so you can run your end-to-end tests directly on a Kubernetes cluster. We will see an example later on. Okay, let's dig a little bit deeper and look at one of the jobs. For each job you can see the console output, but also the test results, CPU and memory statistics, and coverage results if you like. Sometimes your tests fail on your CI infrastructure and you can't reproduce them on your machine. Instead of now SSHing into the build machine, you can pull the image of the failed job from InfraBox with our CLI and run it on your machine. With this, it should be a lot easier for you to reproduce failures in your tests. The last thing I'd like to show you is our example repository. It contains many examples you can use to get started with InfraBox. A more advanced example is the Kubernetes integration. As mentioned earlier, InfraBox can provision a Kubernetes namespace for your job, so you can use it for your end-to-end testing. All you need is to specify the CPU and memory limits for the namespace in the job definition. InfraBox will then provision the namespace and mount the service account into the job like Kubernetes would do. Here's an example how you could now access the namespace using kubectl. That's it for today. If you like InfraBox, please follow us on Twitter and give us some feedback. Thank you for watching.